USS Indiana, America's first true battleship class, sails beneath an overcast sky. Pre-dreadnought design, bridging ironclads to all big-gun dreadnoughts. Laid down in the 1890s, Indiana embodied pre-dreadnought thinking. Compact, heavily armored, prioritizing protection and big gun turrets. Protective belts and armored decks formed a fortified internal citadel. A purposeful hull-wrapped machinery, magazines, and crew spaces. Outer plating separates to reveal frame network and armor boundaries. The waterline belt guarded vital spaces against shell and splinter. The waterline belt guarded vital spaces against shell and splinter. An armored deck curved to deflect fragments into voided volumes. Transverse bulkheads compartmentalized the hull for added survivability. A pronounced bow form cut seas and supported forward turret weight. Aft structure housed shafts, bearings, and steering assemblies within armor. Steering linkages transmitted helm intent to the large balanced rudder. Steam expanded through successive cylinders, extracting energy step by step. High-pressure admission began the cycle, driving the first piston stroke. Low pressure finished expansion, turning a heavy crank and flywheel. Twin engines drove twin propellers for reliability and maneuver authority. Compact Scotch boilers generated the steam that fed the engines. Headers gathered steam, routing supply toward the engine inlets. Exhaust steam condensed, returning as feed water for closed-loop efficiency. Pumps circulated water steadily, stabilizing pressure and temperature. Coal stores flanked boilers, adding endurance and lateral protection. Bearings and seals supported smooth transfer of torque aftward. Propellers converted rotational energy into controlled thrust through water. Mechanical signaling coordinated bridge orders with engine responses. A compact armored box protected engines, boilers, and magazines. Internal closures limited flooding, preserving buoyancy and stability. Deck armor formed a protective roof over critical compartments. Anchor handling gear occupied reinforced spaces near the bow. Main turrets housed large breech-loading guns under heavy armor. Exploded view reveals mechanical layers and armored support rings. Breech movement absorbed recoil, then returned the barrel to battery. Range and elevation concepts governed placement and armor geometry. A circular race supported turret rotation within an armored cylinder. Aft turret balanced the battery and protected vulnerable arcs. Secondary guns addressed faster, nearer threats with quick, aimed fire. Mounts absorbed recoil and returned weapons to steady alignment. Magazines sat deep within the armored citadel for maximum protection. Protected routes connected magazines to gun positions conceptually. Simple range finding and communications, coordinated salvo timing and direction. Mechanical signals relayed intent through armored partitions efficiently. Ladders and hatches enforced orderly movement in emergencies. Support spaces sustained long deployments with limited volume. Ventilation managed heat, smoke, and fresh air throughout machinery spaces. Compartments arranged for compact living and rapid passage between stations. Funnel trunks directed exhaust safely away from sensitive equipment. Armored cabling protected essential circuits from damage. Pumps redistributed fluids for control and compartment management. Ballast and trim systems maintain stability in differing conditions. Bilge keels reduced roll, improving gun platform steadiness. An armored conning tower shielded command during action. Boats and davits supported utility, not depicted in water here. Deck machinery managed anchors and heavy handling operations efficiently. Chains occupied reinforced lockers beneath protected spaces.
Valve gear metered admission and release with rhythmic precision.
Crosshead guided motion, protecting alignment under fluctuating loads. Structural details conveyed strength and maintainable access surfaces. Condensers reclaimed steam energy into reusable feed water. Air pumps improved vacuum and thermal efficiency downstream. Mountings defined safe containment and regulated steam release. Controlled draft balanced combustion with available air supply. Frames and girders created a rigid, compartmentalized backbone. A double bottom added strength and pathways for controlled drainage. The model remains purely studio-based for clarity and consistency. Training gear turned turrets smoothly under armor protection. Elevation mechanisms adjusted angle with controlled, repeatable motion. Recoil systems absorbed energy and restored alignment predictably. Range arcs were planned to cover sectors and approaches. Secondary layout balanced fields of fire and available space. Protected routes minimized exposure between storage and gun positions. Indiana bridged eras between coastal defense and blue water power. Design choices reflected emerging doctrine and industrial capability. Crank assemblies translated reciprocation into continuous rotation. Thrust bearings delivered axial loads into the ship's structure. Stern tubes aligned to shafts while maintaining watertight boundaries. steering hardware converted orders into directional control aft. Switchboards distributed power under armored protection routes. Electric lighting improved visibility in deep internal spaces. Simple signals aided coordination across armored compartments. Compartmentation limited spread of flooding or smoke efficiently. Cross-connects allowed flexible movement of fluids around ship. Lower voids contributed to strength and damage tolerance. The structure closes, restoring the ship's clean external form. Ring rollers distributed turret weight during careful rotation. Pinions engaged internal racks for controlled turret training. Elevation screws provided precise angular adjustment under load. Cradles controlled barrel movement within armored housings. Armored control spaces prioritized protection over wide visibility. Routing preserved communication through compartment boundaries. Bridge coordination translated intentions into mechanical responses. Electrical generation interfaced through robust, serviceable couplings. Distribution maintained ordered, protected power pathways throughout. Ventilation shaped workable environments within armored shells. Penetrations were tightly controlled to maintain integrity. Openings were raised and sealed to resist unwanted ingress. Access routes organized vertical movement between tight deck heights. Stowage systems prevented movement during sea states or maneuvers. Reinforcements dispersed loads along the ship's lower structure. Forms optimized hydrodynamics within practical constraints of era. Armament paired with armor to fit pre-dreadnought doctrine. A museum-grade view. Systems explained, operations deliberately omitted. Indiana's design captured a pivotal moment before dreadnought dominance.